Okay. So a lot of today's notes are review. You probably have seen a lot of this before and know it, but we're just going to have to review it because we're really looking at parallel and perpendicular lines today. So we need to know how to find the slopes of lines, how to rewrite equation lines, and things like that. So starting off, we need to classify slopes. We need to know when it's positive, negative, zero, undefined, things like that. So looking at these different slopes, this first one is going to be a positive slope. It's going up and to the right, so it's positive. Second one, this is a negative slope. It is going down and to the right, so it is negative. Here we have a zero slope. So whenever you have that horizontal line, it's zero. Remember, hoi vox, horizontal, zero, y values. Or this is anytime you have 0 divided by a number, this gives you a zero slope. And the last one, a vertical line will be undefined. That will be vox, vertical, undefined, x values. So anytime you have a number divided by 0, that would give you that undefined slope. Okay? And if I'm going too fast or going too slow, feel free to fill in as much of the notes as you can on your own and then come back and watch the parts that you don't know. All right, so here we're finding slope, looking at graphs and given ordered pairs. Remember, slope, the variable, is going to be lowercase m. Given a graph, you're going to use the rise over the run. Or you can say the change in y's over the change in x's. That little triangle means change. You can count how many are going up, how many are going down. So these graphs are a little hard to see where the points intersect, but you're going to choose 2 points and then you can count the rise over the run. So let's say I choose that point right there, and then I'm going to choose the point where my line intersects my graph. And then I'm going to count my rise. 1, 2, 3. So I went up 3, which was positive. And now I'm going to the left, which means the negative number. I'm going to the left, 1, 2, 3, 4. So I've got 3 over negative 4 would be my slope. Okay, the second one, pretty easy. This is a horizontal line. You've got hoi, horizontal, 0. So my slope equals 0. Didn't have to do any counting there. And then my third graph, again, let's choose 2 points. I'm going to choose where the graph and the vertical axis intersect. Then I'm just going to choose the point right next to it. My slope, we're going up 1 and to the right 1. So up and to the right, that's positive. Rise over 1, 1 over 1. My slope is just 1. Always go ahead and reduce that fraction if you can. All right. If you're given an ordered pair, we are going to have an equation for slope. That's m equals, again, the change in y's. So we could say y1 minus y2 over the change in x's. So x1 minus x2. Right? If it helps, go ahead and label your ordered pairs. You can label this x1, y1, x2, y2. And then we can plug in our values into the equation. M equals y1 is 5 minus y2 is a negative 1, so that turns to a plus 1 over x1, which is negative 2, minus x2, which is 6. 5 plus 1 is 6. Negative 2 minus, negative 2 minus 6 is negative 8. And this reduces to negative 3 over 4. Okay, same thing. M equals y1, which is negative 4, minus 2 over 9 minus 9. That gives me negative 6 over 0. You cannot divide by 0. This would give us an undefined slope. That would be a vertical line. All right, and last one, m equals -3 minus a -3 gives me a plus, -7 minus 0. So -3 minus a -3, -7 minus 0. It gives me 0 over -7. Any number, 0 divided by any number just equals 0. Remember, that one would be a horizontal line. Hopefully I did all my math correct on those 3 problems. Y2, Y1. So that is a review of slope. Going to the next page. This will be 3.5. Write and graph equations of lines. Again, this is more review. We should know slope-intercept form, standard form, and point-slope form. We will talk about these 3. Again, if you want to fill in these notes and come back and just double check them, you can. If you need to keep following along, that's great. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept, or where the graph crosses the y-axis. That's your y-intercept. Okay? So given the graph, we want to write the line in slope-intercept form. So we need to find the slope, we need to find the y-intercept. Pretty basic. Y equals the slope. Let's choose points. I always like to choose my y-intercept and then go from there. So it looks like the next place where it's going to cross perfectly is at the end of that line, going up 2 and to the right, 1, 2, 3, 4, 5. So my slope will be 2 over 5. We've got an x plus b, so my x-intercept is this point down here. We went -3, 0, -3, sorry. 0, -3. So my y-intercept is actually a -3, and that would be your final answer. Okay? Let's do the one directly to the right of that. Y equals, let's find the slope. It looks like we're just going up 1 and over 1, up 1 and over 1, but do notice that is a negative slope, that we will have -1x, or just minus x. And now we need our y-intercept, so that's going to be 0, 2. So y equals -x plus 2 would be that equation of a line. Third one, again, this is going to be a negative slope. My intercept point is 0, 0. It looks like there's another point. So we're going up 1 to the left, to the left 3. Y equals -1/3 x. There is no b. B is 0, so it's not necessary to put plus 0. We'll just leave that blank. And then finally, I see here's my intercept point is going to be 0, 1, 2, 3, 4. My slope, let's see. These graphs again are kind of hard to see where they're intersecting. I think that looks like my next intersection point, honestly. We're going up 1, 2, 3, 4. To the right, 1, 2, 3, 4, 5. So my slope, y equals 4/5 x plus 4. So in all of these, we have our slope right in front of our x, and then our intercept gets added or subtracted depending on its sign to the back of that equation. So that is our first form. Second form, standard form. Love standard form. It's easy, very straightforward. Standard form will be ax plus by equals c. This is a great form, but standard form does not automatically give you the slope. And a lot of times we're going to need to see the slope to tell if our lines are parallel or perpendicular. So we will want to change our standard form into slope-intercept form. That just means we're going to solve for y. All right, so this is a review of, sorry about the bell. This is going to be a review of literal equations. So you're solving a two-variable equation, but you're solving specifically for one of those, in this case, y. So algebra review, you should be able to do this. Solving for y. First step, minus 5x on both sides. 2y equals, we cannot combine the 6 and the 5 because the 6 does not have a variable, the 5 does. So we will have 2y equals 6 minus 5x. Last step, getting the y by itself, we're going to divide by 2. We do want to simplify this, so y equals 6 divided by 2 is 3, minus 5 divided by 2, we will leave it as a fraction, x. So that is our slope-intercept form. Written a little differently, we have y equals b plus mx. Okay, so this is our slope, and our b is 3. Okay, next one, solve for y, minus 3x on both sides of the equation. Negative y equals 5 minus 3x. Divide by negative 1 on both sides. Y equals 3x minus 5. So I'm using the commutative property just to change the order of my right side of that equation right there. Not a big deal. Number 3, minus 6x on both sides. 8y equals negative 16 minus 6x. Divide by 8. Y equals negative 16 divided by 8 is a negative 2. Negative 6 divided by 8 is going to give us 3/4 x. We've got our slope. We've got our y-intercept. And then the last one, minus x. Minus x. 1/2 y equals negative 4 minus x. Here might be a tricky part. Just a reminder, if we're getting rid of this fraction, or we're getting rid of the denominator of a fraction, the opposite of that is going to be to multiply. So 2/1 times 1/2 will cancel out and leave us with 1y or just y. When you multiply the right side, you must put parentheses, multiply by our coefficient, and then distribute. So y equals negative 8 minus 2x would be our final answer there. So we solved all of this for y to get our slope-intercept form. Lastly, we have point-slope form. Point-slope form, you're going to have a point, you're going to have the slope. So here we have y minus y1 equals m times x minus x1. Again, m is the slope, and our point is going to be the y1, or I guess I should say the x1 and the y1 values. So you will plug in a point to the equation. So it says, use to write the equation of a line when given a point x1, y1, and the slope of the line m. So for the first two, we're given the point and the slope. So you just plug it in, really simple. Y minus 4 equals negative 1/2 x minus 2. Here's my slope, and here are my coordinates. 4, 2, 4, 2. Remember that's x1, y1. Okay, same thing for the second one. Y minus y1 equals slope times x minus x1. Okay, these next two a little bit more difficult only because you're not given the slope. We must find the slope first. Then you can choose either point you want. So my slope will be negative 1 minus 6 over 2 minus 4. That's negative 7 over negative 2. which gives us 7/2. So now pick either point to plug into our equation. I'm just going to use the first one. So y plus 1 equals 7/2 x minus 2. Okay, and then again, find the slope. 7 minus a negative gives me plus 1, negative 3 minus 1. So we're left with 8 over negative 4. Our slope will be negative 2. Choose a point, plug it in. I'm going to choose the point this time 1, 1. Y minus a negative 1 equals negative 2 times x minus 1. All right. So that is point slope form. Here's going to be a review for vertical and horizontal lines. This is horizontal, horizontal 0, y values, vertical undefined x values. Okay, so here a vertical line is written in the form of x equals a, where a represents the line x intercept. So we need to see what is the x-intercept here. This point will be negative 1, 2, 3, 0. So the x-intercept is negative 3, so our equation is x equals negative 3. For your horizontal lines, your horizontal line is written in the form of y equals a, where a represents the line's y-intercept. So again, find that intersection point, 0, 1, 2, 3, 4. So our equation here would be y equals 4. Okay. Steady moving along. Also, more review. Parallel lines. Parallel lines have the same slope. Remember, parallel lines go on forever and ever in both directions, and they never intersect, so their slope must be the same. Perpendicular lines are going to have opposite reciprocal slopes. Okay, so opposite means opposite sign. Reciprocal is going to mean you flip the fraction. So some examples, let's just say we'll use 5/7. If that's your original slope, the opposite reciprocal, change the sign, flip the fraction. So 5 over 7, the opposite will be negative 7 over 5. Okay, another example, let's say we start out with negative 1 as our slope. Remember, negative 1 is really negative 1 over 1. So if we wanted the opposite reciprocal, we would say positive 1 over 1, which just is a positive 1. So negative 1 and positive 1 are opposite reciprocals. One more tricky example, 0. The opposite reciprocal of 0 will be undefined. So that would be like a vertical line and a horizontal line intersecting. Those are opposite reciprocals. They're going to be perpendicular to each other. Okay, that's the end of that page. Next page. Here, use the slope to determine if lines A, B, and C are parallel, perpendicular, or neither. Okay, so you will have a section like this on your test. So that's helpful. Test section. So make sure you look at the correct point. So first, I'm going to do the slope of AB. All right. So I need y1, which is 3, minus y2 over x1 minus x2. Okay, that's going to give me a negative 3 over a negative 4, which reduces to just 3/4, so we take away the negative. So my slope of AB is 3 over 4. Now I'm going to do the slope of CD. So we've got 0 minus 3, and we've got negative 1 minus 3. We've got negative 3 over negative 4, which reduces to 3/4, 3/4, and 3/4. These slopes are the same. So since they are the same, my lines are parallel. Okay, same thing for number 2. Go ahead, maybe pause this video, or you can keep playing it. I'm not going to talk. I'm just going to work out the problem and then check your answers, see if you get the same thing for our 2 slopes. The first I'm going to do slope of A, B. I got them to be different. I got negative 5/3 and 1/4. So those are neither parallel nor perpendicular. So that'll be neither. I also don't know why my pen got so thick there. Okay. Some more different examples. For 3 and 4, determine whether the equations are parallel or perpendicular or neither. Okay, so you want to find the slope of both. So it's easy for this first one in 3. My slope is negative 4. Don't have to do any math as long as I know my slope-intercept form. We're great. Notice the second equation is the standard form. So we need to solve for y. So we will have 3y equals 10 minus 12x. I need to divide both sides by 3. Oops. Wrote my division symbol all wonky. And now this is not working. Okay, let's try that again. Okay, so 3y equals 10 minus 12x. There we go. Divide by 3. Y equals 10/3 minus 4x. There, my slope equals negative 4. Negative 4 and negative 4, these lines are parallel. Okay, number 4, we have a y equals negative 7 and an x equals negative 2. Remember, toy, bucks. So this first one, horizontal line, second vertical line. Whenever you have a vertical line and a horizontal line, your lines are perpendicular. Don't have to do any math, just have to do a little bit of thinking. Five and 6. So number 5 says to write the equation perpendicular to 5x plus 3y equals negative 21 that passes through the point negative 5, 1. So perpendicular actually finds the opposite reciprocal slope. Okay, so first we need to find the slope of this equation. So 3y equals negative 21 minus 5x. Divide both sides by 3. Y equals negative 7 minus 5/3 x. So my original slope was negative 5/3. So my opposite reciprocal slope, or I'm going to say the perpendicular slope, needs to be opposite of that, so it'll be positive in the reciprocal. So 3/5. That is my new slope. And I'm going to write this in point slope form since I have a point and I have a slope. So y minus y1 equals slope times x minus a negative 5. And there is my point slope form. Okay, next one we want an equation parallel, so I need the same slope. So parallel slope, let's solve for y. Negative 3y equals 9 minus x divided by negative 3. Y equals negative 3. Negative divided by negative is plus x over 3. So my slope, my parallel slope, going to be the same. My slope here is 1/3. So parallel slope will be 1/3 using the point we're given. Y minus -1 equals 1/3 x minus 3. All right. Finally, some stuff we might not know. These are going to be some theorems. We're going to draw pictures with them. These theorems you might need to use in some proofs. You don't have to name them by name, or like you don't have to use theorem 3.8, theorem 3.9, but you just need to know how to write the theorem, what it says, what it means, and how to identify it in a picture. Okay. So theorem 3.8, if two lines intersect to form a linear pair, of congruent angles, then the lines are perpendicular. Okay, so we will say if M and N form a linear pair, and I'm going to abbreviate LP, with congruent angles, then M is perpendicular to M. So our picture, we need two lines intersecting. We need two angles that are congruent. Oops. So we'll say this is congruent to this angle. Since those two are congruent, this is forming a linear pair, so how many degrees are both of these angles? Oh, they're both 90. So that means that our two lines will say M and N. Okay, next theorem. Two lines are perpendicular, then they intersect to form four right angles. So if M is perpendicular to N, then they form four, and I'm going to say RT angles, right angles. Okay, so you've got M and N intersecting. We are told that M is perpendicular to N, so I know that all of these are right angles. Kind of funky to draw. Theorem 3.10. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So let's say we have ray BA is perpendicular to ray BD, then angle ABC and angle CBD are complementary. For our diagram, we need ray BA, we need ray BD, and then let's draw an interior ray with point C. And we have, if these two adjacent acute angles are perpendicular, then the angles are complementary. So these two would be perpendicular, which would say that they are complementary. Okay, so kind of a lot of notes. I feel like I'm doing a lot of talking. Hopefully, you're still with me, understanding. This is the new part, so hopefully, maybe you skimmed through the first part. Now we're learning some new stuff. We have the perpendicular transversal theorem. If a transversal is perpendicular to one of two parallel lines, it is perpendicular to the other. So perpendicular, go in that blank, and we will say if T is perpendicular to M and M is parallel to N, then T is perpendicular to N. So we need two lines that are parallel, M and N. We need a perpendicular T, and we said that it was perpendicular to M. So since T is perpendicular to M, we also know that it's perpendicular to N. Last one, lines perpendicular to a transversal theorem. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So if T is perpendicular to M and T is perpendicular to N, then M perpendicular to N. Again, two more lines, M and N, with a perpendicular T. Both of these lines are perpendicular, so then we know that M and N are parallel. In this one above it, I forgot to put the parallel angle errors there. Two more things and we're done. So these three are just some examples. What can you conclude from the given information? So in the first one, we are told that angle 1 is congruent to angle 2. So since we know angle 1 is congruent to angle 2, then we know that R will be perpendicular to S. And how do we know this? So if those are congruent, they're forming a linear pair. So then we know that because of theorem 3.8. Again, you don't need to know what theorem 3.8 says specifically. I just don't have enough room to write. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So I just abbreviated it to 3.8. All right. Example 2. N is perpendicular to M. Okay. So since M is perpendicular to N, I know that angle 1, angle 2, angle 3, and angle 4 are all right angles. How do we know this? We know this because of theorem 3.9. If two lines are perpendicular, then they intersect to form four right angles. And last but not least, we have ray BA is perpendicular to ray C. So that is going to tell us that angle 1 and angle 2 are complementary. That would be theorem 3.10, 3.10. If two sides of two adjacent acute angles are perpendicular, then they are complementary angles. So start really learning those couple theorems. Pretty self-explanatory, especially if you see a picture or draw a picture, you'll be able to figure out what they're talking about. Okay, our last notes for today. Hallelujah. Almost there. Okay, so distance from a point to a line. Okay, this is pretty simple. We've got the directions step by step here. Maybe pause the video. Do both of these looking at the steps, then play it. I'll probably just do these without talking, so you can follow along that way if you need to. So go ahead, read the directions, see what you got. So it says distance from a point to a line is the length of the perpendicular segment from the point to a line. The distance between two parallel lines is the length of any perpendicular segment joining the two lines. Use the distance formula to find the length of the given point and the point where the line and the perpendicular segment intersect. Okay? You will need to know the distance formula again. Here are the steps. Write the slope of the line. What is the slope of the line perpendicular to that? Graph the new line from the point given and find the point of intersection. Then you'll use the point of intersection in the given point for the distance formula. Okay, maybe I will do one of these with you and then let you do the second one on your own. Okay, so we're finding the distance from point A to line C. So here I'm given point A. Our first step is to write the slope of the line. So we need the slope of line C. So I'm going to say C slope. Okay? And if we look at that slope, looks like it's going to the right one, down 1, to the right one, down 1. So our slope is just -1. So my perpendicular slope is going to be a +1. Okay, so now using that new slope, I'm going to draw another line using the point A. So I'm going to go up 1 to the right one, up 1 to the right one, down 1 to the left one, down 1 to the left one, down 1 to the left one. Then we can connect those to draw our lines. And we need to find our intersection point. So where do our two lines intersect? Intersection. That is going to be -1, 0. All right. We are finding the distance between that intersection point and our point A. So we also need the coordinate points for point A. Point A, we have the points 1, 2, over 1, up 2. So now I need the distance between A and that intersection point. The distance equals the square root, we can say x1 minus x2 squared plus y1 minus y2 squared. So I said -1 minus 1 squared plus 0 minus 2 squared. That gives me -1 minus 1 is -2. -2 squared is 4. Plus 0 minus 2 is -2. -2 squared is 4. To the square root of 8. Let's go ahead and reduce that. We would get 4, 2, 2, 2. 2 square root 2 would be the distance between the points. All right. Go ahead and try the second one on your own. I will write all the information and you can check your answer. Okay, so you should have gotten the square root of 18, which reduces to 3 square root of 2. Well, end of today's notes. Great job. If you have any questions, please call me over or come talk to me. And we can clarify anything you might not understand. But hopefully a lot of that was a review and nothing new. So now you can just put away your device so I know that you're done with the notes. And I should have already told you what to do next. It's either going to be homework or an activity depending on how much time we have left. All right, thanks guys. Sorry the projector's not working and we have to resort to this craziness. Hopefully I'll have that situation figured out ASAP. Thanks guys. Bye.